Let's jump right into this explainer. There's this fascinating paradox in modern AI right now. We've got these highly fluent systems, right? But they still completely drop the ball on complex enterprise work. Why is that? And more importantly, how on earth do we fix it? Well, today we're unpacking a really crucial concept from the energetic paradigm, EP function 12, or memory as failure to rule conversion. It's a bit of a mouthful, but stick with me, because we're going to explore exactly why this specific function is a massively investable AI capability. It is literally the dividing line between a mere chatbot and a serious, heavy-hitting operational system.
So, why exactly does Fluent AI fail when the real work begins? Well, the answer exposes a massive commercial pain point, a total lack of structural discipline. See, the core issue isn't that the AI lacks vocabulary or computing juice, it's that complex work falls apart when all that smooth, fluent generation isn't disciplined by rigid structure. Without that guardrail, fluency just gives you really articulate, highly persuasive mistakes. Picture an AI generating this beautifully written legal analysis, but it completely misapplies a critical precedent. That's an articulate mistake. And in the enterprise, man, that is a massive liability.
And this brings us to the crucial difference in how memory actually gets applied. Look, ordinary AI memory, it basically just remembers conversational facts. It remembers your name, the vibe of your chat, maybe what you asked it 5 minutes ago. But serious enterprise AI requires something totally different, EP memory. This isn't about just recalling facts. It's a system purpose-built to actively prevent repeated structural mistakes. It's this monumental leap between just remembering what was said and actually enforcing the rules of how work must be reliably executed over and over without fail. To really wrap our heads around why this is such a highly investable capability, we're going to cover the enterprise AI flaw, failure to rule conversion, demand, execution, scalability, and wrap it all up with the investor takeaway.
All right, let's start with part one, the enterprise AI flaw.
Think about high-consequence environments for a second. We're talking enterprise strategy, investor due diligence, contract and legal review, governance systems, document intelligence, agentic execution, the whole shebang. In arenas like these, your casual everyday chatbots completely fall apart. Why? Because an output is only actually valuable if professionals can audit it, correct it, and, implicitly trust it. A consumer chatbot can totally get away with loose reasoning, but an autonomous enterprise workflow where you literally have millions of dollars or huge legal liabilities on the line, yeah, you simply cannot afford those kinds of structural errors. The standard for success here isn't sounding human, it's being flawlessly reliable.
Moving right along to part two, failure to rule conversion.
Let's define what we're actually looking at here. Memory as failure to rule conversion is an operating function that stores not just the content but the actual hard rules learned from failure, correction, and quality control. I really want to emphasize this point. This is absolutely not just another memory feature. Actually, scratch that. It's not a cosmetic writing add-on at all. It's a control function. It dictates exactly how a task has to be framed before the answer is even produced, how it's strictly checked during production, and how the final output is judged. The way this works is through a beautifully precise three-step pipeline. Step 1, detect failure. Step 2, extract the correction. Step 3, create an active constraint. Instead of just, editing a mistake away like a human fixing a typo, a structural mistake is isolated, classified, and converted into a permanent, reusable rule. While ordinary generation just asks, hey, can the model say something plausible, this pipeline ensures a mistake becomes an absolute guardrail for all future work. It literally turns correction into reusable operating intelligence, so the system inherently gets safer and more reliable every single time it catches an error. Talk about a game changer.
All right, part three, demand, stopping recurring mistakes.
So where does the real demand for this come from? It appears the exact moment a repeated failure becomes simply too expensive for a company to ignore. Buyers don't just want persuasive text anymore. They need structurally reliable work. These outputs absolutely must survive brutal review by decision makers, engineers, investors, lawyers, you name it. Institutions are just desperate to reduce drift, eliminate contradiction, and instantly flag unsupported claims. The market is demanding this because teams need methods that expose those hidden contradictions way before they snowball into serious business liabilities. A mistake caught early, that's a learning opportunity. But a mistake repeated in a final public report, that's a full-blown crisis.
It all boils down to this simple reality. Uncontrolled generation gets exponentially more expensive the deeper you deploy it. In a tiny pilot phase, errors are kind of just annoying, right? But as you weave AI deeply into the core of your business, a hallucination or a repeated structural error scales like wildfire and becomes disastrous. If AI is going to keep pushing into these high-value workflows, the demand for this specific control function is absolutely going to skyrocket.
Let's jump into part 4, execution, and specifically, creating active constraints.
Now, execution is only proven when this function is performed repeatedly under intense pressure. What we are really looking at here is a complete transformation of errors. Take an ordinary AI error, like a recurring structural mistake. EP converts that into an active constraint that explicitly dictates what not to do. A hidden reasoning path, that becomes an inspectable quality gate, dictating exactly what must be checked. And an unsupported claim is transformed into a hard evidence boundary, dictating what proof is required and what boundary must remain active. This is how execution happens in the real world. You're taking this abstract, fuzzy concept of learning from a mistake and forcing it into a mechanical, unavoidable checkpoint.
And because that reasoning path is made fully inspectable, the output is judged against rigorous structure, not just stylistic polish. The outcomes of this execution are incredibly tangible and hit right at the bottom line. Proposals become significantly more investable because their underlying structure is crystal clear. Agreements become vastly safer because hidden contradictions are systematically exposed and blocked way before anyone signs anything. Workflows actually become repeatable. And those clunky corporate governance models, they become highly usable because they're finally defining actual operational constraints instead of just throwing around empty corporate buzzwords.
Okay, moving right along to part 5, scalability and organizational learning.
When we talk about scalability in the energetic paradigm, we're not claiming this one function just magically cures every problem in the world. It's really about preserving this exact same operating logic under totally different task pressures. This failure to rule memory can be embedded straight into templates, checklists, software modules, rigorous QA workflows, agent policies, and enterprise copilots. By turning this into long-term organizational learning, this function has a true, proven path toward productization across the entire enterprise. It essentially means the whole organization levels up and gets smarter every single time one little module learns a new structural rule.
If you take one thing away about scalability, let it be this. The surface domain changes, but the structural control remains exactly the same. Whether your AI is grinding through legal review, document intelligence, or orchestrating autonomous agents, sure, the surface content naturally shifts depending on the department, but this function reliably controls the exact same structural failures across the board. Any domain relying on AI for complex work absolutely must eventually solve the structural problem this function addresses. It's a universally required layer for serious AI deployment, for sure.
Which brings us to our final section, part 6, the investor takeaway.
Memory as failure to rule conversion is highly investable simply because it converts a recurring AI failure into a repeatable AP capability. Function 12 isn't some abstract academic theory or a fun weekend science fair project. It connects a very real bleeding neck market pain directly to an executable method and a highly scalable product logic. This is a required system of functions that makes AI deductive, auditable, correctable, and actually operationally useful. In short, it proves out demand, execution, and scalability, answering that big, fundamental question of how AI actually creates lasting value for a business.
So as you look at scaling AI within your own enterprise workflows, you really have to ask yourself a hard question. Is your system just remembering facts, or is it actually learning the rules to ensure it never fails the exact same way twice? Serious AI requires memory that actively stops recurring structural mistakes. Preventing that next failure isn't just some neat technical feature, it's where the real, undeniable enterprise value lies. So the real question is, how will your organization bridge the gap between an AI that just talks and an AI that actually flawlessly executes?